We now go to motion problems. In motion problems, we use a simple formula: distance is equal to speed times time. Okay? So these three things are all connected with each other using this formula. Distance over time is equal to speed. Okay? So from this, we can find any one of the three if we know the other two. Okay? So we basically see this every day in cars, on planes, even when timing a sprint or somebody is running. But in math problems, we can also handle some trickier situations like two trains moving toward each other or boats going against the current. So let's in solving this kind of problems, you follow the simple steps. Number one, identify what is given, and then identify what is required. Number two, you check which formula to use. If you need to rewrite the formula or reorganize the formula to solve for the missing value, and then you can place your information on the table, and then you can continue and solve. We can practice this formula, the use of this formula, by solving some motion problem examples. So the first example, you have two planes leave an airport and fly in opposite direction. One plane flies at 150 miles per hour and the other plane flies 120 miles per hour. How many hours will it take for the two planes to be 810 miles apart? Okay? So, if we draw the diagram, so basically that will also give you everything that you need to know. Let's say plane A goes at 150 miles per hour. This is the airport. And then plane B goes at 120 miles per hour. So we are asked what will be the time for them to be 810 miles apart. So basically, as time goes by, their distance grows bigger, no? So in this case, it's we're given both of the speeds and you would like to get the distance. So to get the distance, so we have the speed is equal to distance over time. So since we would like to get, we are given that, we are asked for the time. So what we need to do is we just need to divide, multiply both sides by time and divide by speed. So that cancels this one, and then you'll have your time is equal to distance over speed. Okay? So when you combine their distances, basically you'll have your you can solve for 810, but we need the distance pala. So let's just multiply both sides by speed. You'll get time times speed is equal to distance. So I think the most appropriate is the third one. Okay? So we'll use this. So we'll get the time. Well, both of them will leave at the same time. So both of them will just use t as a time elapse. Okay? So we will multiply the speed of A, 150 miles per hour, times the time elapsed t in hours, basically, plus 120 miles per hour times in hours. So we need to look what will be the time required to reach 810 miles apart. So as you can see, hours will just cancel out, but t will stay. 150t plus 120t is equal to 810 miles. So combining like terms, you have 270t is equal to 810. Divide both sides by 270. Alright, so that will give you 3 hours. So after taking off for 3 hours, both leaving at the same time from the airport, they will reach a distance of 810 miles from the distance of plane A to plane B. A kayaker can paddle 60 kilometers downstream and return upstream in 12 hours. If he can paddle 5 kilometers with the current in the same time, it takes him to paddle 4 kilometers against the current. Find the speed of the current. Okay. So, let's identify and define first your variables. Okay. Let's start with your paddling speed, the kayaker's paddling speed in the water, let's say V. Okay. This is the paddling speed in still water. So this is just basically the speed without any influence of the current. Then we have C as the speed of the current. Let's say both in kilometers per hour because it's in kilometers and hours. So the downstream speed, when we go downstream, so it's V plus C because it goes through the current. So this is the downstream speed. The upstream, so if he goes against the current, it's the paddling speed minus the current because it interferes with the direction. Okay, so let's take a look at the equation. It says there we have 60 kilometer downstream and return in 6 hours. Okay, so downstream it's 60 kilometers and then return back and forth by, so basically both are 60 kilometers. So both in 12 hours. Okay. So how are we going to write that down? So we can write it as, remember we have your speed is equal to distance over time. We have we have the time is equal to distance over speed, or our distance as time times speed. These are our formulas. So to look at the 12 hours, that's a total time. Okay? So it will take 12 hours for the whole trip. So we can combine the distance, the time took going down and going up. So we can get the speed and then the distance and then the speed to get the time. So we will use this. T is equal to D over S, distance over speed. So it will be 60 downstream and then it goes to the speed of V plus C and then plus the time to take going up, 60 upstream, V minus C is equal to 12 hours. So this is our first equation. Second sentence tells us if he can paddle 5 kilometers with the current in the same time, it takes him to paddle 4 kilometers against the current. Okay? So it tells us that the 5 kilometers downstream with the current in the same time, it takes him 4 kilometers against the current upstream. Okay? So, it says there, 5 kilometers downstream is equal to 4 kilometers of your upstream. So, rearranging this, we can get a relationship between v and c. So we can multiply both sides by v squared minus c squared. Remember, that's the difference of two squares. That will cancel this and you will be left with v minus c times 5. And here it's 4 times v plus c. If you expand this, if you expand this is just v minus c, v plus c. That's why the denominators are cancelled out. Okay? So, combining this, 5v minus 5c is equal to 4v plus 4c. Combining like terms, we'll have 5v minus 4v. We have 4c plus 5c. You'll have v is equal to 9c. We will keep that. We will use this relationship to substitute in this first equation. We'll have 60 over 9c plus c. So that's 10c. Plus, we are substituting v. 60 over 9c minus c, it's 8c is equal to 12. Then, we can solve for c. Just get this equation. And then start to the next page. Okay. So we can multiply both sides by 40c. So that will just cancel this out, and then it will have 4 times 60. It's 240 plus 40 divided by 8 is 5. So 5 times 60 is 300. Is equal to 12 times 40, it's 480c. So 240 plus 300 is 540 is equal to 480c. Divide both sides by 480. Okay. We'll get the speed of the current as 540 over 54 over 48, basically. So 54 divided by 48 is just 9 over 8, or 1.125 kilometers per hour. That's our speed of our current. Okay. So that is just being what is being asked. In any case, you would like to still get the paddling speed in still water, we can do so by substituting C here, 9 times 1.125. So multiplying it, 9 times 1.125 will be 10.125 kilometers per hour. So this is how fast the kayaker is paddling if there is no current. For a third example, you have two cyclists, we have X and Y, starting together on a 1,000 meter circular track. Cyclist X rides at 12 meters per second and cyclist Y rides at 9 meters per second. How long will it take for cyclist X to be exactly one lap ahead of cyclist Y? So, two things are important to understand. Number one is they are riding at the same direction because they are racing, basically. And then one is moving faster than the other. So there will come a time that they will be exactly one lap ahead of the slower, which is Y. So that is where the question is coming from. How long will it take for cyclist X to be exactly one lap ahead of cyclist Y? So since they are moving in the same direction, we can get the relative speed, which is faster minus slower. So 12 meters per second minus 9 meters per second. So that is 3 meters per second. That also tells us that every second their distance increases by 3 meters. Okay? So, the formula that we use, we are asked for the time. So, time is equal to distance over speed. Okay? So, since the distance that we're looking for is exactly 1 lap and the whole circular track is 1,000 meter. So it will take 1,000 meters to get into 1 lap. Okay? So to solve for the time, we will use the speed as the relative speed, 3 meters per second. And the time to cover is 1,000 meters. That will be their distance. That will be their distance to make it 1 lap ahead of the other. So, with that being said, 1,000 divided by 3, that's 333.3 seconds. And in minutes, or when you divide it by 60, so that is 333. So that is at does it ask for a unit? No. Or 5 minutes 33.3 seconds. Okay. So it will take 333.333 seconds for cyclist X to be exactly 1 lap ahead of cyclist Y.